Hello, and welcome to Quiet Learning for Sleep. This is your peaceful space to unwind, to let go of the day, and to drift into deep, restful sleep while learning softly about our universe. Here, we take gentle journeys through calm ideas, stories from science and nature, space and time, history and life, all whispered at a soft pace, without rush, without noise, and without pressure. You do not need to focus or remember anything. This is learning the quiet way, where your mind floats and drifts and rests, while curiosity stays softly awake in the background. If you'd like, before you get comfortable, you can subscribe and gently like this video. Doing it now means you won't forget later, and it helps others like you find this calm, sleepy corner of the world. Now, allow your breath to slow just a little. Let your shoulders relax. Let your thoughts soften, like clouds drifting across a calm evening sky. There is nowhere you need to go, nothing you need to do, and nothing expected from you here. This time belongs to rest, comfort, and gentle curiosity. And if you drift to sleep along the way, that is not only allowed, it is welcome. So settle in, let yourself melt into stillness, and allow your mind to float quietly as we begin. Before we move anywhere at all, we begin by standing completely still. Imagine yourself outside, somewhere quiet, far from noise and motion. The ground beneath you is steady and familiar. The air is calm. Above you stretches the night sky, vast and dark, dotted with soft points of light. This is where every journey into the universe truly begins, not by moving outward, but by becoming aware of where you already are. The earth turns gently beneath your feet. You do not feel it, but you are moving at more than 1,000 kilometers per hour as the planet rotates. At the same time, Earth is traveling around the sun, and the sun itself is moving through the galaxy. Even now, standing still feels peaceful, only because motion is relative. Everything is always moving together, quietly, in harmony. As you look up, the sky appears like a dome, but it is not a ceiling. It has no edge, no wall, no boundary. The stars you see are not arranged on a surface. They are scattered through immense depth, layered across distances so large the mind cannot grasp them all at once. Some of that light left its source years ago. Some of it began its journey before you were born. The darkness between the stars is not empty. It is filled with space, real, physical space, stretching in all directions. Even the closest stars are unimaginably far away. If the Earth were the size of a grain of sand, the nearest star would be kilometers away. Most of what you see above you is separation, distance, quiet emptiness, and that vast spacing is what gives the universe its calm. Take a moment to notice how the sky does not rush. The stars do not flicker with urgency. They hold their positions gently as the earth turns beneath them. Constellations rise and fall, slowly over hours, repeating the same motions night after night, year after year. The sky teaches patience simply by existing. The moon may be visible tonight, glowing softly. It is close compared to everything else, only a little over 1 second of light away. Light leaves the moon and reaches your eyes almost instantly. This closeness is why the moon feels familiar, comforting, and present. It is our nearest companion in space, moving with us through the dark. Beyond the moon lies the sun, even though you cannot see it at night. Its light takes a little more than 8 minutes to reach Earth. That means when you see sunlight, you are seeing the sun as it was 8 minutes ago. Even here, in everyday life, you are always looking slightly into the past. The stars above you exist on entirely different timescales. The light from the nearest stars takes years to arrive. Light from distant stars takes thousands of years. Some of the faint points you see may no longer exist as they once were. Their light continues onward, traveling quietly through space, long after the moment it was created. Standing on Earth, you are already participating in deep time. You are receiving ancient messages carried by light across vast distances. You are connected to events that happened long before memory, long before history, long before humanity learned to look upward with understanding. The atmosphere above you acts like a gentle filter. It softens starlight. It protects you from harmful radiation. It creates the illusion that the sky is close, when in reality, it is only a thin shell wrapped around the planet. Beyond it, space begins almost immediately. Only a few dozen kilometers up, the air thins to nothing, and Earth gives way to the open universe. The fact that you can stand here comfortably, breathing, warm and safe, is something rare. Earth is not just a place you live. It is a shelter, a small island of stability in an ocean of vacuum. Every step outward into the universe depends on this quiet starting point. As you look upward, notice how the sky invites curiosity without demanding attention. You do not need to understand distances or names to feel the scale. The vastness communicates itself instinctively. It relaxes the mind by reminding it that there is nothing to solve, nothing to control, nothing to rush. The observable universe, the part of reality we can see, begins right here, at your eyes. It expands outward at the speed of light, limited not by physical walls, but by time itself. We can only see as far as light has been able to travel since the universe began. That means the observable universe has an edge, not because space ends, but because time does. Beyond that edge, light has not yet reached us. The universe may continue far beyond what we can observe, but for now, our vision stops where the oldest light still arrives. This idea is not meant to feel overwhelming. Instead, it offers peace. There are limits to what can be seen, and within those limits, there is already more than enough beauty, mystery, and scale to fill a lifetime of quiet wonder. From this still place on Earth, everything begins gradually. There is no jump, no sudden acceleration, just awareness expanding outward, slowly, layer by layer, distance by distance. The universe does not pull you. It allows you to drift. You are not small in a way that diminishes you. You are small in a way that connects you to everything else that is small, and everything large that emerged from small beginnings. Atoms formed stars. Stars formed elements. Elements formed planets. Planets formed life. The universe is not something separate from you. It is something you are standing inside of, breathing within, moving with. Even now, the atoms in your body were formed in ancient stars. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were created long before Earth existed. Standing still becomes an act of connection. The ground beneath you belongs to a planet formed from cosmic dust. The air you breathe is part of a thin envelope shaped by gravity. The sky above you is an opening into distances that extend far beyond imagination. You do not need to go anywhere yet. The journey has already begun simply by noticing where you are. Earth is not the center of the universe, but it is the center of your experience, and that is enough. As your breathing slows, allow the sky to remain above you without effort. Let the stars hold their places. Let the darkness feel spacious rather than empty. This is the calm foundation from which all exploration unfolds. In this stillness, the universe does not feel cold or distant. It feels patient, quiet, open. And as you rest here, standing on Earth beneath an endless sky, the observable universe waits, ready to unfold slowly, gently, one distance at a time. When you are ready, the sense of stillness begins to widen. You do not rush upward or accelerate suddenly. Instead, the feeling is more like drifting, as if the ground beneath you gently releases its hold. Earth remains below, steady and familiar, while your awareness slowly lifts, moving outward into the space just beyond your home. The first thing you notice is how close everything still feels. Even as you rise, Earth does not shrink quickly. The continents, oceans, and cloud patterns remain visible, slowly rotating beneath you. The planet turns with quiet confidence, its motion smooth and unhurried. This closeness reminds you that leaving Earth's neighborhood does not mean abandoning it. Distance grows gradually, almost kindly. Below you, the atmosphere thins into delicate layers. The air fades from blue to deep indigo, then to black. This fragile shell, only a tiny fraction of Earth's size, is all that separates the surface from the vacuum of space. It is a reminder of how thin the boundary truly is, and how protected life on Earth has been by this nearly invisible veil. As the atmosphere disappears, sound vanishes with it. Space offers no echoes, no wind, no vibration. Silence here is complete, but not empty. It feels full, expansive, almost welcoming. In the silence, movement feels softer, smoother, as though friction itself has been gently removed. The moon now becomes more prominent, no longer just a glowing disk in the sky, but a world in its own right. Its surface shows texture, craters layered upon craters, vast plains of ancient lava, and long shadows cast by low sunlight. The moon is airless, silent, and still, preserving its history with no erosion to erase it. Every mark you see has remained for millions or even billions of years. The distance to the moon is about 384,000 kilometers. Light crosses this space in just over 1 second. In cosmic terms, this is nothing at all, a single heartbeat of time. And yet, this small distance has shaped human history profoundly. The moon stabilizes Earth's tilt, influences tides, and has guided calendars, myths, and imagination for as long as humans have looked upward. As you drift beyond the moon's orbit, Earth and moon appear together, a paired system moving through space. Earth glows blue and white, while the moon reflects sunlight softly, pale and calm. Their shared motion is gentle, almost intimate, a reminder that gravity binds objects not through forceful pulling, but through quiet, persistent connection. Beyond the moon, distances begin to stretch more noticeably. Earth slowly shrinks into a bright sphere, still detailed, still beautiful, but now clearly separate from you. The sun, though unseen in the night sky, becomes more conceptually present. You are moving within its gravitational domain, part of a vast system shaped by its steady pull. The sun is not just a source of light and warmth. It is the anchor of Earth's neighborhood. Every planet, asteroid, and grain of dust here moves in response to it. Light from the sun travels outward in all directions, taking just over 8 minutes to reach Earth. That brief journey already places sunlight firmly in the past by the time it arrives. As you continue outward, you begin to sense how light itself defines distance. Space is not measured in kilometers alone, but in time. How long light takes to travel becomes the most natural way to understand scale. 1 second to the moon, 8 minutes to the sun, hours to the outer planets, years to the stars. Earth's neighborhood includes more than just planets. Invisible to the eye are countless pieces of debris, dust grains, tiny meteoroids, and fragments left over from the solar system's formation. They drift quietly, rarely colliding, each following its own slow orbit. Space here is vast enough that even with all this material, emptiness still dominates. Passing outward, you leave behind the region where human-made satellites orbit. These artificial companions form a thin shell around Earth, brief, temporary objects compared to the ancient bodies of space. Their presence is fleeting, lasting decades at most, before they fall back or drift away. Beyond them, the universe returns to its natural rhythm. The sun's light grows subtly dimmer as distance increases, though it remains strong for a long time. Space does not darken suddenly. Instead, brightness fades slowly, like a lamp seen from farther and farther away. Shadows soften. Contrast decreases. Light becomes less commanding and more ambient. Earth is now a bright point rather than a world. Its atmosphere glints faintly, a thin halo of blue around a shrinking sphere. Everything familiar, cities, oceans, mountains, collapses into a single dot. And yet, nothing important is lost. Meaning does not diminish with size. Connection remains. This gradual retreat offers perspective rather than separation. Earth's neighborhood feels intimate because it is where you began, but it is also part of something much larger. Leaving it does not feel like departure. It feels like expansion. The solar system stretches far beyond what you can see from Earth. Even now, as you move away, the sun still dominates this region. Its gravity reaches far, guiding the orbits of planets, comets, and icy bodies that wander in distant paths. You are still well within its influence. Time begins to feel different as distances grow. Motion slows, not physically, but perceptually. There is more space between landmarks, more quiet between moments. This slowing is calming, allowing thoughts to drift without urgency, mirroring the pace of the universe itself. Looking back one last time, Earth appears fragile yet resilient. A small island of warmth and life surrounded by darkness. Its brightness stands out not because it is large, but because it is alive. In the vast stillness of space, life creates its own kind of light. Ahead of you lies open space, not empty, but spacious. Distances increase gently, objects become fewer. The solar system begins to reveal its true scale, where planets are separated by vast stretches of quiet. Here, patience becomes natural, and waiting feels effortless. Leaving Earth's neighborhood is not about speed or escape. It is about understanding how closeness gives way to vastness, and how vastness, in turn, creates calm. The universe does not rush you outward. It allows you to drift, to adjust, to breathe. You remain within the sun's domain, still held gently by gravity, still illuminated by distant light. Earth no longer fills your view, but it has not disappeared. It has simply taken its place, one world among many, moving quietly through a universe built on patience and time. In this expanding stillness, the journey continues naturally. Distances stretch, silence deepens, awareness widens, and without effort, you find yourself ready to see how small even this familiar neighborhood truly is. As your awareness continues to drift outward, the familiar objects of Earth's neighborhood begin to rearrange themselves in your mind. Distances stretch gently. What once felt close now feels properly spaced. The solar system slowly reveals its true nature, not as a tight cluster of planets, but as a vast, mostly empty region where small islands of matter float in a sea of quiet space. From Earth, the planets often feel arranged neatly, almost side by side, as they appear in diagrams and illustrations. But here, from a widened perspective, you see how misleading that impression is. Each planet occupies its own enormous territory, separated from the next by tens or hundreds of millions of kilometers. Between them lies not chaos, but stillness, long corridors of emptiness, where nothing interrupts the slow passage of time. The inner planets, Mercury, Venus, Earth, and Mars, circle the Sun within a relatively compact region. Even so, the distances between them are immense by human standards. Space between Earth and Mars, for example, can stretch from about 56 million kilometers to over 400 million, depending on where the planets are in their orbits. These distances change constantly, yet always gradually, unfolding over months and years, rather than moments. The Sun remains the central presence here. Its gravity extends outward, guiding everything within the solar system in smooth, predictable paths. Yet even the Sun, vast as it is, occupies only a tiny fraction of the space it governs. If you imagine the solar system as a vast cathedral, the Sun would be a single glowing candle at its center, illuminating a room far larger than the flame itself. As you continue outward, Mars recedes behind you, becoming just another small point of reflected light. Ahead lies the region between Mars and Jupiter, where the asteroid belt drifts quietly. This belt is not a dense field of rocks, but a sparse collection of objects spread across a wide zone. Most asteroids are separated by hundreds of thousands of kilometers. Collisions are rare. Motion here is slow, orderly, and calm. Asteroids vary in size from tiny pebbles to bodies hundreds of kilometers across. Many are remnants of early planetary formation, material that never became part of a planet. They orbit patiently, unchanged for billions of years, preserving ancient records of the solar system's beginnings. In their stillness, they carry memory rather than movement. Beyond the asteroid belt, the scale of the solar system expands dramatically. Jupiter dominates this region, not only because of its size, but because of its gravitational reach. It influences the orbits of countless objects around it, shaping the architecture of the entire system. Yet even Jupiter, immense as it is, floats within vast stretches of emptiness that separate it from Saturn and the outer worlds. Distances between the outer planets are so large that light itself takes significant time to cross them. Light from the Sun needs about 40 minutes to reach Jupiter, and well over an hour to reach Saturn. By the time sunlight reaches Uranus and Neptune, it has been traveling for hours, spreading thinner, softer, and less commanding with every passing minute. This gradual thinning of sunlight changes how space feels. Shadows soften, contrast fades. The solar system becomes less bright and more subtle, as if the universe itself is encouraging stillness. Warmth becomes memory rather than sensation. Motion slows perceptually, even though orbital speeds remain constant. The planets themselves follow precise paths, tracing ellipses around the sun. These orbits are not random. They are the result of delicate balances formed billions of years ago. Once established, they persist with remarkable stability. Planets do not wander aimlessly. They glide, repeating their paths with quiet reliability. Beyond Neptune lies a region that challenges intuition, the Kuiper Belt. Here, countless icy bodies orbit in a broad, flattened disk. Pluto is one of these objects, but it is far from alone. The Kuiper Belt stretches outward for billions of kilometers, populated by frozen remnants of the solar system's formation. These objects move slowly, completing orbits that last hundreds of years. Even the Kuiper Belt is not the true edge of the solar system. Far beyond it lies the Oort cloud, a vast spherical halo of icy bodies extending perhaps a light year from the sun. These distant objects are so far away that their existence is inferred rather than observed directly. They drift in near total isolation, bound weakly to the sun, moving so slowly that change becomes almost imperceptible. At this scale, the solar system no longer feels like a collection of planets. It feels like a gentle gravitational field with a few small islands of matter embedded within it. Space dominates everything. Matter becomes rare. Emptiness becomes the defining feature. If the sun were reduced to the size of a grain of sand, the nearest planet would be several meters away. The Oort cloud would extend for kilometers in every direction. The nearest star would be dozens of kilometers away. These comparisons help reveal how isolated our solar system truly is within the galaxy. And yet, isolation here does not feel lonely. It feels spacious. The vast distances create room for calm, for reflection, for unhurried movement. Nothing collides frequently. Nothing rushes. Everything unfolds according to gentle laws that operate over immense spans of time. The solar system moves as a whole through the Milky Way, orbiting the galactic center once every 230 million years. Every planet, moon, asteroid, and comet participates in this shared journey. Even as planets circle the sun itself is traveling, carrying its entire system along with it. This layered motion, moons around planets, planets around the sun around the galaxy, creates a nested structure of movement. Each layer moves smoothly, without conflict. Nothing jerks or jolts. Motion here is continuous, fluid, and deeply calming. Seen from far away, the solar system would be almost invisible. The planets reflect little light. The sun would appear as a single bright point among billions of others. Everything you recognize as home would blend quietly into the background of the galaxy. Understanding this scale does not diminish Earth's importance. Instead, it deepens appreciation. Life emerged in a quiet corner of an immense structure, protected by distance, shielded by emptiness, allowed to develop without constant disruption. The solar system's vastness acts as a buffer. Most of the universe is far away. Most events unfold too slowly or too distantly to disturb inner worlds. This separation creates stability, a rare and valuable condition. As you drift farther outward in awareness, the sun no longer feels central. It becomes one star among many. The solar system itself begins to feel like a single unit, a small bubble of warmth and motion, suspended within a much larger structure. This realization brings a gentle quiet. There is no urgency to go faster, no need to reach an edge. The perspective itself is the destination. Space does not demand exploration. It allows observation. Here, in this expanded view, the solar system rests as a complete self-contained system. It has shape, structure, rhythm, and memory. And beyond it lies something far larger, not yet explored, but patiently waiting. The farther you drift from the sun's familiar glow, the more natural stillness becomes. Distances stretch. Time broadens. Thought slows. The universe reveals itself not through motion, but through scale. In this quiet understanding, the solar system settles into its true form. Not a crowded place of constant activity, but a wide, gentle expanse where a few small worlds trace long, graceful paths through endless space. When the solar system finally settles into the background, something subtle but profound happens. For the first time, the sun no longer feels like the center of everything. It becomes a single star among many, still important, still familiar, but no longer dominant in your awareness. The darkness around you deepens, not because there is less light, but because distances have expanded so greatly that light itself feels more delicate. Ahead, scattered through space, lie the nearest stars, not clustered tightly together, but separated by vast, silent gaps that define the true scale of the universe beyond our planetary home. The closest star to the sun is Proxima Centauri. Despite being our nearest stellar neighbor, it is still over 4 light-years away. That distance is so large that light, moving at the fastest speed anything can travel, needs more than 4 years to cross it. If the solar system were reduced to the size of a coin, Proxima Centauri would still be kilometers away. This is the defining characteristic of interstellar space. Not objects, but separation. Stars are not arranged like lanterns along a path. They exist as isolated islands of matter, each surrounded by enormous volumes of emptiness. Proxima Centauri is a red dwarf star, small, dim, and long-lived. It shines far more faintly than the sun, invisible to the naked eye from Earth, despite its proximity. Red dwarfs are the most common type of star in the universe. They burn their fuel slowly and steadily, lasting trillions of years. While massive stars blaze brightly and die young, red dwarfs glow quietly, conserving their energy over unimaginable timescales. In many ways, they are the universe's most patient inhabitants. Nearby, Alpha Centauri A and B form a binary pair, orbiting one another in a slow, graceful dance. These two stars are closer in size and brightness to our sun, and from a distance, they appear as a single point of light in Earth's sky. Together with Proxima Centauri, they form a small stellar family, moving through the galaxy as companions. Yet even within this group, the distances are vast. Space does not crowd stars together. It allows them room to exist without interference. As you drift among these nearest stars, you begin to notice how quiet everything feels. There are no sudden movements, no dramatic flashes, no sense of speed. Stars move, but they do so slowly, tracing paths around the galactic center over hundreds of millions of years. Even when stars orbit one another, their motion is calm and deliberate, guided by gravity rather than forceful interaction. This slowness is not emptiness, it is stability. Between stars lies the interstellar medium, a thin mixture of gas and dust spread so sparsely that it would feel like a perfect vacuum to any human sense. And yet, this faint material is essential. Over immense spans of time, it gathers under gravity, forming new stars and planetary systems. The spaces between stars are not dead zones. They are nurseries waiting patiently for change, carrying the raw ingredients of future worlds. Light behaves differently here. From Earth, the stars seem fixed, but in reality, each one is moving through space with its own velocity and direction. Over tens of thousands of years, constellations slowly distort, their familiar shapes stretching and reshaping. The night sky you know is temporary, a snapshot in an ever-changing cosmic arrangement. The universe does not freeze its patterns. It evolves them gently, almost imperceptibly. As distance increases, even the nearest stars begin to feel isolated from one another. Each star carries its own gravitational domain, its own system of planets or debris, its own surrounding cloud of particles. The space between these domains is so large that interactions are rare. Collisions between stars are almost unheard of. The galaxy is vast enough that even billions of stars can move without frequently disturbing one another. Some of the stars you encounter are similar to the Sun, burning hydrogen in steady equilibrium. Others are cooler, redder, and smaller. A few are hotter and brighter, shining blue or white. Their energy output far greater, but their lifespans much shorter. Every star represents a different balance of mass, temperature, and time. Together, they form a population shaped not by chaos, but by predictable physical laws, unfolding over billions of years. Here, among the nearest stars, the concept of a light year becomes intuitive rather than abstract. A light year is not a measure of time, but of distance. The span light travels in 1 year, and even the nearest stars are multiple light years away. This means that looking at a star is always an act of looking into the past. You never see a star as it is now. You see it as it was, when the light began its journey toward you. This delay is not something to fear or correct. It is simply how the universe communicates. Information travels at a finite speed, and patience is built into reality itself. Nothing arrives instantly. Everything takes time. This naturally slows perception, encouraging calm rather than urgency. As you drift farther, the stars no longer feel like destinations. They feel like reference points, markers scattered through space, each one quietly existing without demanding attention. You could travel for years at the speed of light and still find yourself surrounded mostly by darkness, punctuated occasionally by distant suns. This is the true nature of the universe at human scale, not crowded, not chaotic, but spacious beyond imagination. The nearest stars also remind you how rare encounters truly are. Civilizations, if they exist elsewhere, would be separated by distances so vast that communication itself becomes a challenge spanning years or centuries. The universe is not designed for constant interaction. It favors isolation, reflection, and long periods of quiet continuity. In this region of space, the Milky Way is still present, but its structure is not yet obvious. You are within one of its spiral arms, surrounded by stars that share a similar orbit around the galactic center. These stars move together like leaves carried along a slow-moving river. Their individual motions are gentle variations within a much larger flow. Gravity continues to guide everything without effort or noise. There are no engines, no propulsion systems, no external commands. The universe moves itself, guided by simple rules applied over immense durations. The result is not disorder, but harmony, a quiet choreography playing out on scales that stretch beyond instinctive comprehension. As you rest among the nearest stars, there is no pressure to go farther, no need to reach a boundary. Understanding deepens simply by remaining here long enough to feel the scale. The stars do not rush you. They do not signal. They remain where they are, glowing steadily, content in their long lives. From this vantage point, Earth is unimaginably distant, a faint, invisible point lost among countless others. And yet, nothing essential has been lost. Awareness has expanded, not diminished. The universe has not grown colder. It has grown calmer. Here, among the nearest stars, the observable universe begins to feel less like a place to be crossed and more like a state to be entered, a condition of vastness, patience, and quiet continuity. And in that condition, there is nothing to do but drift, observe, and allow understanding to unfold slowly, without effort. As your awareness continues outward, individual stars begin to lose their sense of isolation, not because they are suddenly close together, but because patterns slowly emerge. What once felt like scattered points now reveal subtle groupings, star fields that share a common motion, a common origin, or a common destiny. These are not tight clusters, but loose neighborhoods, places where stars drift together through space, carried along by the same galactic currents. Stars are not born alone. Most form inside vast clouds of gas and dust, collapsing slowly under gravity. When these clouds fragment, dozens, hundreds, or even thousands of stars can ignite within the same region. At first, they are close enough to feel like a family, glowing within a shared cradle of gas. Over time, this cradle disperses, and the stars begin to drift apart, each following its own orbit around the galaxy. Yet long after their birthplace fades, these stars still carry a shared motion, a subtle signature of their common origin. As you move through these stellar neighborhoods, you begin to sense how motion replaces distance as the organizing principle. Stars may be separated by light years, yet still travel together, like leaves floating on a wide, slow river. This shared movement is gentle and persistent. Over millions of years, these neighborhoods stretch, distort, and eventually dissolve, blending back into the general star population of the galaxy. Some stellar neighborhoods remain more tightly bound. Open clusters, for example, contain hundreds or thousands of stars, still loosely held together by gravity. These clusters glow softly, their stars often young, bright, and hot. They illuminate surrounding space, creating scenes of quiet beauty rather than intensity. Open clusters are temporary structures. Over time, gravitational interactions pull them apart, scattering their stars across the galaxy. Other groupings are far older and more stable. Globular clusters are dense, spherical collections of stars that orbit the outskirts of galaxies. Each contains hundreds of thousands, sometimes millions, of stars packed closely together. These stars are ancient, among the oldest objects in the universe, and they glow with a softer, warmer light. In globular clusters, stars are close enough to appear almost continuous. Yet even here, collisions are rare. Space remains dominant, even in the densest stellar environments. Drifting through a globular cluster would feel surreal. The sky would be filled with stars in every direction, yet the silence would remain complete. Motion would still be slow. Gravity would guide everything gently. Even in this crowded environment, urgency would be absent. Time would stretch, just as it does everywhere else in the universe. Beyond clusters, star fields begin to merge into the broader structure of the Milky Way. Here, the density of stars increases gradually. The dark between them becomes less absolute, softened by the combined glow of countless distant suns. This is the region where the night sky begins to resemble a luminous haze, rather than a scattering of individual points. From Earth, this haze appears as the Milky Way, a pale band of light stretching across the sky. From within it, the Milky Way feels less like a band and more like an environment. Stars surround you in all directions, yet still leave enormous distances between one another. The galaxy is not a solid structure. It is a vast, rotating system where stars trace long arcs around a central mass. Every star field you encounter participates in this motion, sharing a slow, graceful orbit that takes hundreds of millions of years to complete. Stellar neighborhoods also contain invisible companions. Many stars host planets, asteroid belts, and clouds of debris. These systems are hidden in the darkness, detectable only through subtle effects on starlight. Yet they are common. Planetary systems are not rare exceptions. They are a natural outcome of star formation. Wherever stars are born, planets tend to follow. This realization adds a quiet richness to the star fields around you. Each star may be accompanied by worlds, some barren, some icy, some perhaps warm and complex. These worlds orbit silently, unnoticed from afar, adding layers of depth to every point of light. Space is not just populated by stars. It is populated by possibilities, spread thinly across unimaginable distances. The farther you drift, the more you notice how the galaxy balances complexity and calm. There are countless objects, yet interactions are rare. There is constant motion, yet no turbulence. Everything follows predictable paths, shaped by gravity acting patiently over time. Even dramatic events like supernovae are rare on human timescales. Most stars live quiet, steady lives, shining gently for billions of years without interruption. Light from distant star fields blends together, creating gradients rather than points. The concept of a single star becomes less important than the collective glow. This glow is not harsh. It does not overwhelm. It softens the darkness, giving space a faint texture rather than filling it completely. Darkness remains dominant, but no longer absolute. Here, in these broader stellar neighborhoods, the idea of direction begins to lose meaning. There is no up or down, no center or edge. The galaxy curves around you subtly, its structure hinted at rather than fully revealed. You are inside something too large to see all at once. Understanding comes gradually, through accumulation rather than revelation. Time continues to stretch. Events that seem dramatic from Earth become gentle ripples when viewed across millions of years. Stars form, stars age. Some eventually fade or explode, seeding space with heavier elements. These processes repeat endlessly, yet always slowly. Nothing feels rushed. Nothing demands attention. As you remain within these star fields, a sense of belonging replaces the idea of exploration. You are not passing through something foreign. You are moving within a system that follows the same rules everywhere. The same physics that shaped Earth operates here. The same atoms exist. The same forces apply. This continuity is deeply calming. It suggests that the universe is not hostile or indifferent, but consistent. Wherever you go, the same quiet principles apply. Change happens, but it happens slowly. Structure emerges, but it emerges gently. The star fields gradually thicken as you approach the inner regions of the galaxy. The density of stars increases. Their combined light becomes more noticeable. Yet even here, emptiness remains vast. The Milky Way may contain hundreds of billions of stars, but it is so large that space still dominates. Stars remain islands, not crowds. From this perspective, the universe begins to feel less like a collection of objects and more like a continuous environment, a medium through which stars drift like currents through water. Motion is everywhere, yet it is smooth and predictable. Nothing collides violently. Nothing tears itself apart without reason. As your awareness settles into this understanding, the urge to move faster fades completely. There is no advantage to speed here. Everything unfolds at the pace it needs. Distance becomes something to inhabit rather than overcome. In these stellar neighborhoods, the observable universe feels expansive, but not overwhelming. Large, but not chaotic. Ancient, but not static. The stars do not compete for attention. They coexist, each contributing quietly to a structure far larger than any one of them. Here, surrounded by star fields stretching in every direction, you can rest within the galaxy itself, not as an outsider looking in, but as a presence carried along by the same slow rotation, the same gentle gravity, the same patient unfolding of time. As the surrounding star fields grow denser and more continuous, a larger structure slowly begins to reveal itself. What once felt like a scattered population of stars now feels like a vast system, not crowded, but organized, shaped by gravity acting over immense spans of time. This is the Milky Way galaxy, your home galaxy, a slow-moving spiral of stars, gas, dust, and dark matter, turning quietly through space. From within it, the Milky Way does not announce itself clearly. There are no sharp edges or visible borders. Instead, it is sensed through patterns, the gradual thickening of stars in certain directions, the soft glow that fills the sky, where countless distant suns blend into a luminous haze. The galaxy surrounds you completely, extending in every direction far beyond what can be seen at once. The Milky Way is a spiral galaxy, shaped like a flattened disc with gently curving arms. These arms are not solid structures, but regions of higher density, where gas and dust compress as they orbit the galactic center. Within these arms, stars are born more frequently, illuminating the galaxy with young, bright light. Between the arms lie quieter regions, older populations of stars drifting patiently along their paths. At the center of the Milky Way lies a dense core, crowded with stars and shrouded in thick clouds of dust. Hidden within this core is a supermassive black hole, not a violent presence, but a calm gravitational anchor around which the galaxy slowly turns. This black hole does not consume stars indiscriminately. It simply exists, shaping motion nearby, while remaining almost entirely invisible. The galaxy's disk stretches about 100,000 light-years across. Even traveling at the speed of light, it would take 100,000 years to cross from one side to the other. And yet, this immense structure is thin compared to its width, with most stars confined to a relatively narrow plane. Above and below this plane, star density drops rapidly, and darkness returns. Surrounding the disk is the galactic halo, a vast spherical region containing older stars, globular clusters, and enormous amounts of dark matter. This halo extends far beyond the visible disk, forming an invisible framework that holds the galaxy together. Dark matter does not emit light, but its gravitational influence shapes the Milky Way's rotation, preventing it from flying apart. You are located far from the galactic center, in one of the spiral arms known as the Orion Arm. This region is calm, stable, and relatively uncrowded, an ideal environment for planetary systems to persist undisturbed for billions of years. The Sun and its planets follow a long, nearly circular orbit around the galaxy, completing one full revolution approximately every 230 million years. As the Milky Way rotates, stars do not rush around the center. Their motion is smooth and measured. Each orbit takes hundreds of millions of years, and changes unfold slowly. Constellations shift over tens of thousands of years. Galactic structure evolves over billions. Nothing in the galaxy happens quickly by human standards. Looking outward from your position, the Milky Way appears as a luminous band stretching across the sky. This light comes not from nearby stars, but from countless distant ones, packed closely together in the disk. Their combined glow creates a soft, milky appearance, the feature that gave the galaxy its name long before its true nature was understood. Within the galaxy, stars vary widely in age. Some are newly formed, surrounded by glowing clouds of gas. Others are ancient, having burned steadily for billions of years. Some have already ended their lives, leaving behind white dwarfs, neutron stars, or black holes, quiet remnants drifting invisibly through space. Despite containing hundreds of billions of stars, the Milky Way remains mostly empty. Average distances between stars are measured in light years. Even in the densest regions, space dominates. This emptiness is not a flaw. It is what allows stability, longevity, and calm. Stars rarely collide. Planetary systems remain intact for vast spans of time. The galaxy is not static. Gas flows slowly through spiral arms. Star formation rises and falls. Old stars migrate inward or outward over millions of years. Yet all of this happens gently, without sudden disruption. The Milky Way is not a place of constant drama. It is a place of quiet evolution. Beyond visible stars, the galaxy contains enormous clouds of gas and dust, the raw material for future stars and planets. These clouds drift slowly, shaped by gravity and pressure. Over time, they collapse in places, igniting new stars that add to the galaxy's slow renewal. Creation here is continuous but unhurried. The Milky Way is also home to countless planetary systems. Most stars are now believed to host planets. Some of these planets orbit close to their stars, locked in intense heat. Others drift far out, frozen and dark. A few may lie in regions where liquid water can exist, quietly circling their suns for billions of years. From this perspective, Earth feels neither central nor insignificant. It is one example among many, formed by the same processes that operate everywhere. The galaxy does not favor any single location. It allows complexity to emerge wherever conditions permit, then lets it persist or fade according to gentle, universal laws. The Milky Way itself is not alone. It moves through space as part of a small group of galaxies, accompanied by companions both large and small. Yet from within it, the galaxy feels complete, a self-contained system with its own rhythm, its own history, its own future. Time within the galaxy flows differently than it does in human experience. A lifetime is less than a blink compared to a galactic orbit. Civilizations rise and fall, while stars barely change. The galaxy provides a backdrop so vast and steady that it makes patience feel natural. As you remain within this structure, motion loses urgency. Distance becomes familiar. Vastness no longer overwhelms. Instead, it settles into a quiet understanding. The Milky Way is not something to cross or escape. It is something to inhabit, to drift within, to belong to without effort. The galaxy turns steadily, carrying its stars, planets, and clouds with it. There is no sound, no vibration, no visible motion from this rotation. Only the knowledge that everything is slowly, calmly in motion together. Here, within the Milky Way, the observable universe feels less abstract. It becomes a place with shape and structure, governed by simple principles applied patiently over unimaginable spans of time. Nothing here demands attention. Nothing insists on meaning. And yet, meaning emerges naturally from the quiet continuity of it all. As your awareness rests within this immense spiral of stars, there is nothing more to do. The galaxy moves, time passes, light travels, and you remain gently suspended within a system so large and so calm that effort becomes unnecessary. As the Milky Way settles into the background, something profound changes in scale. The galaxy that once felt immense now becomes a single presence among many. It does not vanish, but it no longer fills awareness. Instead, space opens further, revealing that the Milky Way is part of a larger neighborhood, a quiet gathering of galaxies drifting together through the dark. The nearest major companion to the Milky Way is the Andromeda Galaxy. Even from this expanded perspective, Andromeda does not feel close. It lies more than 2.5 million light-years away. Light leaving Andromeda began its journey toward you long before modern humans existed. When you look in its direction, you are seeing a memory from deep prehistory, carried patiently across intergalactic space. Andromeda is larger than the Milky Way, containing perhaps 1 trillion stars. It is a spiral galaxy as well, similar in structure, but grander in scale. Its arms curve outward gracefully, filled with clouds of gas, dust, and countless stars. Yet despite its size, Andromeda appears faint from Earth, a soft smudge in the sky. Distance diminishes even the largest structures, turning entire galaxies into gentle glows. Between the Milky Way and Andromeda lies a vast expanse of intergalactic space. This space is even emptier than the space between stars. Matter here is spread so thinly that even atoms are rare. And yet, gravity still operates across this emptiness, binding galaxies into loose groups that drift together over billions of years. The Milky Way and Andromeda are members of the Local Group, a collection of more than 50 galaxies, most of them small and faint. These dwarf galaxies orbit larger ones like quiet companions, shaped by gravitational tides. Some are irregular in shape, stretched and distorted by interactions. Others are smooth and spherical, slowly losing gas and fading over time. The Local Group is not tightly bound. Its galaxies move slowly relative to one another, tracing long arcs through space. Over billions of years, some will merge, others will drift farther apart. Nothing happens quickly. Even a collision between galaxies unfolds over hundreds of millions of years, with stars passing by one another harmlessly due to the immense distances between them. When galaxies merge, there is no sudden explosion, no violent chaos. Instead, stars continue on their paths, guided by gravity into new orbits. Gas clouds compress, triggering waves of star formation. Over time, 2 galaxies blend into one, their structures reshaped gently. These mergers are creative rather than destructive, giving rise to new forms without erasing the old entirely. Beyond Andromeda, more galaxies appear. The Triangulum Galaxy, faint and graceful. The Magellanic Clouds, small companions orbiting the Milky Way. And countless dwarf galaxies barely visible, even with powerful telescopes. Each is a system of stars, planets, and space, complete in itself, drifting quietly through the vastness. From this distance, individual stars no longer matter. They merge into collective light. Galaxies become the new points of reference, each one an island universe containing billions of suns. The universe scales upward naturally, without sharp transitions, encouraging patience and calm as perspective widens. The distances between galaxies are immense. Light takes millions of years to cross from one to another. Communication, travel, or interaction across such distances would require timescales far beyond human experience. This separation creates a profound quiet. Each galaxy exists largely alone, evolving according to its own internal rhythms. Intergalactic space is not entirely empty. Thin filaments of gas stretch between galaxies, forming bridges of matter shaped by gravity. These filaments are faint and diffuse, barely detectable, yet they form part of a vast cosmic web that connects galaxies across the universe. This web is the large-scale structure of reality, not rigid or mechanical, but organic and flowing. As awareness drifts farther, the local group itself becomes a single point within a larger structure. Groups of galaxies cluster together, forming associations bound by gravity. These clusters contain hundreds or thousands of galaxies, drifting together through space, like slow-moving schools of fish in a cosmic ocean. Yet even clusters are separated by enormous voids, regions where galaxies are rare or absent. These voids dominate the universe by volume. Most of space contains almost nothing at all. This emptiness is not accidental. It is a natural outcome of gravity shaping matter into filaments and knots, leaving vast regions untouched. From here, the universe begins to feel like a quiet breathing structure, dense regions connected by faint threads, surrounded by immense stillness. Nothing crowds, nothing presses. Everything has room to exist without interference. Light continues to travel outward, carrying images of distant galaxies toward you. Each photon arrives with ancient information, telling a story of how a galaxy looked millions of years ago. Some of the galaxies you perceive may no longer exist in the same form. Some may have merged, faded, or transformed entirely since their light began its journey. This delay is not loss. It is the universe's way of preserving memory. The observable universe is not a snapshot of the present. It is a layered archive of the past, arranged by distance and time. The farther you look, the deeper into history you see. Galaxies come in many forms. Spirals like the Milky Way and Andromeda rotate gracefully, their arms slowly winding. Elliptical galaxies are smoother and more uniform, often formed through mergers. Irregular galaxies lack clear shape, shaped by interactions and tides. Each form represents a different evolutionary path, unfolding patiently over billions of years. Despite their differences, all galaxies share common ingredients: stars, gas, dust, dark matter, and time. They obey the same physical laws everywhere. There are no special regions where different rules apply. This consistency gives the universe its calming predictability. As scale increases, motion feels even slower. Galaxies drift rather than travel. Clusters evolve rather than change. The universe does not hurry toward any destination. Expansion continues gently, stretching space itself without resistance or sound. From this perspective, the Milky Way's journey feels modest. It is one spiral among countless others, drifting within a small group, itself part of a larger flow. And yet, nothing is diminished by this realization. Importance is not measured by size or centrality. It arises naturally wherever complexity exists. The night sky from Earth hides this immensity behind apparent simplicity. A few thousand stars are visible to the naked eye, yet each one belongs to a galaxy containing billions more. Each faint smudge hides a universe of its own. The calmness you feel now comes not from emptiness, but from abundance spread thinly across space. Here, among nearby galaxies, urgency dissolves completely. Distances are too large for haste to matter. Time stretches into a continuous present. Nothing demands action. Everything invites observation. The universe does not reveal itself all at once. It unfolds layer by layer, scale by scale, rewarding patience rather than speed. You are not meant to reach an edge quickly. You are meant to drift, to allow understanding to settle naturally. As awareness remains here, suspended among galaxies, the sense of self grows quieter. Perspective expands without effort. The mind no longer tries to grasp the whole. It simply rests within it. This region of nearby galaxies is still only a small part of what exists. Far beyond lie clusters, superclusters, and structures so large they challenge imagination. But there is no need to go there yet. Even here, the universe already feels vast enough to soften thought and slow breath. Galaxies continue their slow motion. Light continues its long journeys, and space continues to expand gently between everything. Nothing breaks the silence. Nothing interrupts the calm. And within this calm, the observable universe feels less like something to explore and more like something to inhabit. A quiet, expansive presence that allows you to rest inside its scale without needing to understand it completely. As nearby galaxies begin to fade into the background, a new scale quietly takes shape. Individual galaxies no longer feel like destinations or landmarks. Instead, they become elements of something larger, subtle groupings, bound together by gravity over immense distances. These are galaxy clusters, vast assemblies where hundreds or thousands of galaxies drift together through space, connected not by closeness, but by shared motion and deep time. Galaxy clusters are the largest structures held together by gravity alone. Within them, galaxies orbit a common center of mass, tracing slow, complex paths over billions of years. The distances between galaxies inside a cluster are still enormous, often measured in millions of light years. Yet gravity links them into a coherent whole. Motion here is not chaotic. It is gentle, predictable, and patient, unfolding on timescales far beyond everyday experience. Between the galaxies of a cluster lies something unexpected. Not emptiness, but a thin, diffuse gas filling the space between stars and galaxies alike. This intracluster medium is incredibly hot, heated by gravity as the cluster formed. It glows faintly in X-rays, invisible to human eyes, but present everywhere within the cluster. This gas outweighs all the stars in the cluster combined, forming a vast, unseen ocean through which galaxies slowly drift. Dark matter plays an even greater role. Though it cannot be seen directly, its gravitational influence shapes the cluster's structure, holding galaxies together and guiding their motion. Without dark matter, clusters would fly apart. Instead, they remain stable for billions of years, slowly evolving as galaxies merge, drift, and rearrange themselves within the gravitational web. From this perspective, clusters feel less like crowded places and more like gentle gatherings. Galaxies rarely collide directly. When they do interact, it happens slowly, over hundreds of millions of years. Stars pass by one another without contact. Entire galaxies can merge without sudden violence, blending their shapes and star populations into something new, reshaped but continuous. As awareness drifts farther outward, clusters themselves begin to arrange into even larger patterns. They are not scattered randomly. Instead, clusters gather along vast filaments, forming superclusters, enormous structures spanning hundreds of millions of light years. These superclusters are among the largest recognizable patterns in the universe, not bound tightly by gravity, but shaped by it over cosmic time. Superclusters do not rotate or behave like single objects. They are loose associations, slowly stretching and evolving as the universe expands. Within them, clusters drift relative to one another, connected by filaments of gas and dark matter that form part of the cosmic web. These filaments are faint and diffuse, yet they trace the large-scale architecture of the universe, like invisible threads. Between these filaments lie vast cosmic voids, regions where galaxies are rare or absent. These voids dominate the universe by volume. They are not empty in an absolute sense, but they contain so little matter that they feel like deep stillness made visible. Void regions expand gently over time, growing larger as matter flows slowly toward denser areas. From this scale, the universe begins to resemble a quiet, breathing structure. Dense knots of galaxies connected by faint filaments, surrounded by immense spaces of near emptiness. This pattern did not arise suddenly. It formed gradually from tiny fluctuations in the early universe, amplified over billions of years by gravity's patient pull. Time becomes even less urgent here. Processes unfold so slowly that change feels almost theoretical. Superclusters evolve over time spans comparable to the age of the universe itself. What you see at this scale is not motion, but arrangement. A snapshot of a structure still forming, still adjusting, still expanding. Light traveling through clusters and superclusters carries stories from deep history. Photons leaving distant galaxies begin their journeys long before Earth existed, passing through intergalactic gas, skimming past clusters, weaving through the cosmic web. By the time they arrive, they have crossed regions that no longer exist in the same form, preserving moments that cannot be revisited directly. At this distance, the expansion of the universe becomes more apparent. Space itself stretches gently between clusters. Galaxies move away from one another, not because they are traveling through space quickly, but because the space between them is expanding. This expansion is smooth and uniform, without sound or resistance, reshaping distances everywhere at once. Clusters closer together may remain gravitationally bound, resisting expansion locally. Others drift apart, carried by the universe's overall growth. This balance between gravity and expansion creates the large-scale patterns you now perceive. Islands of matter separated by ever-growing seas of space. Despite this immense scale, nothing feels chaotic. The universe does not tear itself apart. It expands calmly, evenly, guided by laws that operate everywhere in the same way. There is no edge you can reach, no boundary you can collide with. Expansion happens within space itself, allowing everything to move apart without needing direction. As awareness rests among clusters and superclusters, individual galaxies lose their importance entirely. They are still present, still complex, still full of stars and planets, but they no longer dominate perception. Instead, the universe is understood as a continuous structure, shaped by gravity, time, and expansion acting together. The sheer size of these structures softens thought. There is no practical way to imagine crossing a supercluster. Even light takes hundreds of millions of years to traverse one. Distance becomes abstract, almost poetic, defined more by patience than by measurement. In this environment, stillness feels natural. Nothing invites urgency. Nothing suggests completion or arrival. The universe does not rush toward an end. It simply continues unfolding, layer by layer, scale by scale. From here, the Milky Way is no longer visible as a distinct object. It blends into the background of countless other galaxies, each contributing a tiny amount of light to the whole. Identity dissolves gently into pattern, without loss or erasure. Clusters continue their slow dance, merging occasionally, separating at other times, all while space expands quietly around them. The cosmic web remains delicate, yet resilient, holding structure without rigidity. Here, within the largest gravitational structures the universe has formed, the observable universe begins to feel less like a collection of things and more like a condition, a state of spaciousness, order, and time stretched wide. The mind no longer tries to track individual motion. It rests within the scale itself, allowing vastness to replace detail. Understanding becomes intuitive rather than analytical, as awareness remains here, suspended among clusters and voids. The universe feels complete in its openness. There is nothing missing, nothing pressing, nothing unresolved. Beyond this scale lies the horizon of what can be observed, a limit not imposed by walls, but by time and light. But even before reaching that boundary, the universe has already offered more than enough space to rest within. Here, among galaxy clusters and superclusters, the observable universe settles into a quiet, steady presence, expansive, ancient, and endlessly patient, inviting you simply to remain, to breathe, and to drift. As awareness continues to expand beyond clusters and superclusters, the universe begins to feel less like a place filled with objects and more like an immense field of distance itself. Galaxies grow faint and sparse, not because they stop existing, but because light has traveled for so long that only the brightest, most ancient structures still reach you. At this scale, distance and time merge into the same concept. To look farther outward is no longer just to see farther away. It is to see farther back into history, toward moments closer and closer to the beginning of everything you can observe. The observable universe does not end with a wall or an edge in space. It ends with a limit in time. Light has only had a finite amount of time to travel since the universe began, and so there is a horizon, not a boundary you could ever reach, but a gentle fading of visibility. Beyond this horizon, light simply has not arrived yet. Space may continue, perhaps endlessly, but it remains unseen, not because it is forbidden, but because time has not allowed its light to reach you. As you drift toward this horizon, galaxies appear younger and less structured. Their shapes become irregular, unfinished. Spiral arms are faint or absent. Elliptical forms dominate, often small and compact, glowing intensely with youthful stars. These early galaxies are closer in time to their formation, still assembling themselves from gas and dust. Star formation here is more active, more frequent, yet still unfolds slowly by any human standard. Even at the edge of observation, nothing happens suddenly. Light arriving from these distant galaxies began its journey more than 10 billion years ago. It left when the universe itself was young, when matter was denser, when galaxies were closer together, when expansion had not yet stretched space to its present vastness. As that light traveled, space expanded beneath it, elongating its wavelength, shifting it gently toward redder colors. This stretching does not distort the message. It softens it, slowing it, aging it gracefully before it reaches you. At greater distances, galaxies begin to blur into faint points, then into subtle smears of light, barely distinguishable from the darkness. The universe grows quieter visually, not because there is less happening, but because your window into it narrows naturally. The farther you look, the fewer photons reach you. Vision itself becomes selective, favoring the earliest and brightest events. Eventually, even galaxies fade, and what remains is a uniform, gentle glow, the cosmic microwave background. This is the oldest light that can be observed, released when the universe cooled enough for light to travel freely for the first time. Before this moment, the universe was opaque, filled with charged particles that scattered light endlessly. When those particles finally combined into neutral atoms, light was released in all directions at once, filling space completely. That light has been traveling ever since, stretched and cooled by the universe's expansion, until it now appears as a faint microwave glow, permeating all of space. It arrives evenly from every direction, not as an image, but as a quiet presence. This is not light from stars or galaxies. It is light from the universe itself, a memory of the moment when visibility began. Standing at this edge of observation, you are not looking outward so much as backward. You are seeing the universe at different ages depending on distance. Nearby galaxies show recent history. Distant ones reveal earlier chapters. The cosmic background shows the earliest chapter accessible at all. Time is layered into space, arranged naturally by the speed of light. Here, concepts like direction and location lose their meaning. Every direction leads to a similar horizon. Every observer, anywhere in the universe, sees their own observable boundary, shaped the same way. There is no central viewpoint, no privileged location. The universe looks roughly the same from everywhere, not because it is uniform, but because expansion and time shape observation equally for all. Beyond this horizon, there may be more galaxies, more clusters, more structures stretching far beyond imagination, or the universe may curve back on itself, or it may extend infinitely. Observation cannot decide this, and there is no urgency to know. The observable universe is not incomplete. It is complete in what it allows to be seen. The expansion of space continues gently here, just as it does everywhere else. Galaxies beyond a certain distance recede faster than light, not because they are moving through space at that speed, but because space itself expands between you and them. Their light will never reach you, not due to barriers, but due to time stretching endlessly forward. This is not loss. It is simply how the universe grows. At this scale, even gravity yields to expansion. Structures larger than clusters are not bound together. They drift apart slowly, carried by the universe's steady growth. The cosmic web stretches thinner over time, filaments elongating, voids widening, distances increasing quietly without resistance. This is not an ending. There is no collapse, no sudden emptiness. The universe does not fade. It opens. It becomes more spacious, more patient, more silent. Motion slows perceptually, not because things stop, but because distances grow faster than interactions can keep up. At the edge of what can be seen, the universe feels vast enough to dissolve any remaining urgency. There is nothing beyond this point that needs to be reached. No destination that promises completion. The observable universe already contains more depth, history, and scale than thought can fully absorb. Here, awareness can rest completely, no longer tracking objects, no longer counting distances, no longer anticipating what comes next. The universe simply exists, extended calmly in every direction, bounded only by time and light. What lies beyond observation does not press inward. It does not demand explanation. It remains open, spacious, and unknown in the gentlest possible way. The universe does not hide itself. It reveals exactly as much as time allows. At this horizon, stillness is complete. Light arrives softly. Space stretches quietly. Time flows without markers. The observable universe holds you within its limits without confinement, offering perspective without pressure. And in this vast calm, nothing feels unfinished. The journey outward has not reached an edge. It has reached understanding. The universe does not end here. Observation simply pauses here, naturally, without loss or regret. Beyond the edge of the observable universe, nothing dramatic happens. There is no wall, no sudden darkness, no collapse into emptiness. Instead, what exists is a limit of information, a horizon defined by the speed of light and the age of the universe. Technically, this horizon is called the cosmic event horizon, and it marks the boundary beyond which light emitted today will never reach us, even given infinite time. This is not because space ends there, but because space itself is expanding. Every moment, new regions slip beyond observational reach, not by moving away through space, but by being carried outward as space stretches between all things. This quiet expansion sets the ultimate boundary of what can ever be known through observation. The universe has been expanding since its earliest moments, described mathematically by solutions to Einstein's field equations in general relativity. This expansion is not an explosion from a center, but a uniform stretching of space everywhere at once. Every galaxy sees other galaxies moving away, with speed proportional to distance, a relationship known as Hubble's law. At sufficiently great distances, this recession speed exceeds the speed of light, not in violation of relativity, but because relativity limits motion through space, not the expansion of space itself. This distinction is subtle, but important, and it explains why some regions of the universe are permanently unobservable. As space expands, wavelengths of light traveling through it are stretched, a process called cosmological redshift. Light emitted as visible radiation from distant galaxies arrives as infrared or microwave radiation by the time it reaches us. This redshift is not caused by motion in the traditional sense, but by the gradual stretching of space itself as the light moves through it. Measuring this redshift allows astronomers to calculate distances, ages, and expansion rates, turning faint light into a quiet record of cosmic history. Even here, at the boundary of observation, the universe speaks softly through physics rather than spectacle. Beyond the observable universe may lie regions filled with galaxies similar to our own, following the same physical laws, containing stars, planets, and perhaps even life. Or the universe may curve in ways that loop space back on itself. Or it may extend infinitely. Current cosmological models allow for all of these possibilities. Importantly, none of them require urgency or resolution. The universe does not demand that everything be known. It allows uncertainty to exist as a stable condition, not as a problem to be solved immediately. On the largest scales, the universe appears remarkably uniform. Measurements of the cosmic microwave background show that matter and energy are distributed almost evenly, with only tiny fluctuations, 1 part in 100,000, that later grew into galaxies and clusters. This uniformity suggests that the universe underwent a brief period of extremely rapid expansion early in its history, known as cosmic inflation. Inflation smoothed out irregularities, stretched space to enormous size, and set the initial conditions for everything that followed. Though inflation lasted only a fraction of a second, its effects define the structure of the entire observable universe. As expansion continues, galaxies not bound by gravity drift farther apart. Over trillions of years, distant galaxies will fade from view entirely, their light stretched beyond detectability. Eventually, observers in the far future would see only their own local group of galaxies, surrounded by darkness. This is not destruction, but isolation caused by distance. The universe becomes quieter visually, even though it remains full of structure and history. Knowledge contracts gently, not violently. From a thermodynamic perspective, the universe also moves toward increasing entropy, a gradual trend toward equilibrium. Energy spreads out, temperature differences diminish, and processes slow. Stars will eventually exhaust their fuel. Stellar remnants will cool. On unimaginable timescales, the universe approaches a state sometimes called heat death, not as a catastrophic ending, but as a quiet fading into uniformity. Even this idea carries no urgency. It unfolds over times far beyond anything a mind can meaningfully track. Yet throughout all of this, physical laws remain unchanged. The same constants apply everywhere. Gravity continues to shape motion. Quantum fields continue to fluctuate. Space and time continue to exist as a connected fabric. Nothing collapses into chaos. The universe does not rush toward an end. It simply continues, expanding, cooling, and evolving according to principles that are both simple and profound. Standing conceptually beyond the edge of observation, the idea of here and there dissolves. Every observer carries their own observable universe with them. There is no absolute vantage point, no universal center. Each point in space is equally valid as a place from which the universe unfolds. This symmetry is deeply calming. It suggests that meaning is not tied to position, scale, or perspective, but arises naturally wherever awareness exists. In this final stillness, the universe no longer feels like a destination or a journey. It becomes an environment, one that is vast, lawful, patient, and remarkably gentle. The technical details do not diminish the calm, they enhance it. Knowing that expansion follows precise equations, that structure emerges from tiny fluctuations, that time and space are woven together mathematically. All of this adds quiet stability rather than complexity. For quiet learning for sleep, this is the natural resting place, not an ending, but a settling. The universe does not conclude. Observation simply reaches its natural limit. Beyond that, imagination may wander, but it is not required. What can be seen has already offered more than enough scale to quiet thought and slow breath. Here, beyond urgency and beyond edges, the universe remains open, spacious, and complete in itself. Light continues to travel, space continues to stretch, time continues to flow, and nothing asks you to follow it further. You have not reached the end of the universe. You have reached a place where understanding can rest.
you.